All right, so here is our practice worksheet on the transformations of graphs of functions. And the first half of this, we're just going to be either describing a translation or we're going to be writing the equation for a function when we are given the translation. So for problem number 1, they want to know how is f of x equals x squared minus 4 obtained from the graph of g of x equals x squared. Basically, all they're asking is this is your parent function. And they want to know how do you get this. The only thing different in the two equations is this minus 4. So what does that minus 4 do to the graph of my parent function? Well, it comes after the squared part, so that's going to be your up or down. That is going to make it shift down 4. Okay. Number 3 is asking the exact same type of question. So if you'll go ahead and skip down to number 3, see if you can tell me what the extra stuff added to this equation. Now, added to your parent function, what does this extra stuff do? What does the negative in front do? What does the minus 5 inside do? I'll give you just a minute, and then I'm going to put it up here, and you can check it. Okay, so that negative reflects it across the x-axis. And that minus 5 that's inside, that is my left or right shift. And it's inside, so I'm going to do the opposite. So I'm going to move it to the right 5. So now for problem 2, they want me to write an equation of the function g of x. So my equation is going to be g of x equals something. Okay? So they want me to take this function right here, f of x equals the absolute value of x, move it 5 to the right, up 3, and flip it over. So I know I'm going to have absolute value. To flip it over, well, let me put my x in here. To flip it over, I'm going to have to put a negative out front. When I want it to move to the right 5, I'm going to have to put a minus 5 in here to move it to the right 5. And then 3 units up, I'm going to put a plus 3 after. And that is your equation for g of x. All right, number 4 is the exact same type of question. I want you to write an equation for g of x that takes f of x equals x squared and shifts it 6 to the left and 7 down. Okay, I'll give you just a minute and then I'll put it up here, see how you did. Alright, here's my x, and I know I've got to have a square because my parent function was an x squared. To move it to the left 6, I'm going to put a plus 6 inside because I do the opposite, and that's my left and right. And then to make it shift down 7, I put a minus 7 afterward. All right, for numbers 5 and 6, describe how the graphs of quadratic equations move by circling the direction, shape, horizontal motion, and vertical motion of each function. All right, so this one, I know it's going to graph a parabola because it's an x squared. Okay, and yeah, the square is outside the parenthesis, but it goes with that x. This negative out in front is going to make it open upside down. Then I'm going to take my ordered pair from here, the opposite and the same. That is your vertex. And then when we're talking about horizontal motion, well, to get from the origin to here, I'm I'm going to have to go right, 2, down, 1. And is this the normal size or shape for a parabola, or is it wide, or is it skinny? Well, my coefficient is a -1, so it's going to be normal. Number 6, this is a positive 1/3 coefficient. Because it's positive, it's going to open up. Then we got to figure out what our ordered pair is going to be. I don't have anything in parentheses with my x. So the first part of my ordered pair is going to be a 0. And I'm going to take the same as the number that comes after the squared part. So that's 2. So my vertex is 0, 2. Horizontal motion, it does not move left or right, so that is neither. Vertical motion, this 2, I have to move it up 2. And then as far as the shape, remember, when you have a number that is between 0 and 1 as your coefficient for your x squared term, it's going to be wide. All right. And so now, we're going to take a look at some more absolute value and some more cubic functions. I've even got one quadratic still on here. Okay, we did lots of quadratics on a previous sheet, but we're still going to do another one on this one. I want to save the 2 absolute value for last. We'll come back to those. So let's skip over here for this one. This, I've got to figure out my ordered pair. I've got to figure out the shape of it because it's a cube. This is one of those squiggles. Okay? And normally the squiggle looks like this. But I've got a negative out in front. So it's going to flip that upside down. So let's start by finding our vertex point. Our vertex, opposite, same. It's going to be -3, 1. But instead of going up on the right side, I'm going to have to go down on the right side, and it goes up on the left. So here's the way I think about this. If you took, if you pretend this graph is a piece of string, and you grab the arrows on each end, and you pull it so the string is nice and tight, isn't that going to graph a line with negative slope? It is. So that's how I think about it. I know that if it's going to have a negative number in front, it's got to be pointing down on the right-hand side. Okay, these are just sketches. Number 9 is another cubic. So normally it looks like this. We've got to figure out our shift. My shift for this one, there's nothing with my cube, so that is 0, and then up 1. But I have a negative in front of my x cubed again. So that means the right-hand side has to point down, and the left-hand side is going up. All right, let's finish up the cubics here real quick. This one, once again, cubics usually look like this. For this, I have a shift to go left 1, and then I don't have anything afterwards, so that's -1, 0. It's positive out in front, so my right side is going to go up, left side is going to go down. And once again, if you pretend that that is a string, and you pull the ends of that string so that it's tight, that gives you a line with positive slope. I know the right-hand side has to be going up. Now, this one, the shape is different because it's a squared. So I know it should look like this. I've got to find my vertex point, opposite, same. So that is 2, -4. It's positive out in front, so I know it's going to open up. excuse me. And that's a 1 coefficient, so it's kind of normal width. Okay, there you go. So now, those were just sketches. Remember, I told you we're going to be a little bit more particular with our absolute values. That's why I saved them for last. Okay, I know that absolute value graphs and looks like a V. So now I've got to find my vertex point, opposite, same, just like we did on the others. So 2, -2. Here's where we've got to be very specific. Okay, in front of my absolute value, that is a 1. I'm going to put it over 1. And remember, we use that number kind of like slope. It's not exactly like slope, but it's kind of that way. The top number tells you whether to move up or down. The bottom number tells you to go left and right that amount. Okay, so I've got 1 over 1. So what I'm going to do from here, I'm going to go up 1 and both directions 1. Okay, I can do it again. From here, go up again and 1 again. And that is how we're going to get our V shape and be more accurate than we were with our others. All right, number 10, once again, it's going to be a V shape because it's absolute value. But I got a negative out in front, so it's going to be upside down. My point is going to be opposite, same, so -3, 2. My numbers in front is, -1 over 1. So from this point, I'm going to go down 1, both directions 1. And then I can do it again, to go down 1, both directions 1 again. So then on the back side of that sheet, you've got some common graph practice. You need to match these equations to these graphs at the bottom. Okay? You will not use all of these. You will not use any of them more than once. And all I need you to do is write whatever your equation is, write it, next to the graph. And you can mark them out as you go since you're not going to repeat any of the same answers. Okay? We will check that next time.